Simply listing the first few terms is not sufficient to define a unique sequence. The nth term must be given. To see this, we look and we say 2, 4, 8 looks the same as 2, 4, 8. These must have the same formula. No, they don't, because when you get to the fourth term, it changes. Okay, so this one's pretty simple. We're just squaring 2, and then we're raising 2 to the third power. So here's the first term. So 2 to the first power is just 2. Here's the second term, 2 to the second power. Here's the third term, 2 to the third power is 8. Here's the fourth term, 2 to the fourth. So we're just raising 2 to whatever term we're at. This one is way more complicated, okay? A lot harder to see. We come down here and we say, okay, what's going on? Well, this is the first term, second term, third term, fourth term. And they tell us the pattern is we're multiplying and then subtracting 1 every time. So we're multiplying 2 times 2 is 4, take away 1. 3 times 2 is 6, take away 1. 4 times 2 is 8, take away 1. Okay, so the overall formula then is that. We come on down here. Let's see if I can get rid of that. We have what's going on here? Well, here's our terms 1, 2, 3, 4, and we're squaring and adding 1. So we square 1 and we add 1 and we get 2. And we square 2 and we add 1. 4 plus 1 is 5. And we square 9 and we add 1. We square 4 and we add 1. Okay. So now our job is to try to see the pattern. And that could be exciting or terrifying, depending on how you look at it. Well, 1 goes to 4, the difference is 3. 4 goes to 7, the difference is 3. 7 goes to 10. Something's changing by 3 every time. So what we have here is, oh, by the way, I should list out the terms. First term, second term, third term, fourth term, fifth term. What's going on here? That's the question. And let's see, the answer is we are taking, we're saying 3 times n, and we're subtracting 2. Is that right? Well, let's see. Would it work for the first one? 3 times 1, take away 2, that's 1. Okay. How about for the second one? 3 times 2 is 6, take away 2 is 4. 3 times n, that's the third one. 9, take away 2 is 7. 3 times 4, take away 2 is 10. Yes, so I think that's what we'd say. We'd say 3n, take away 2 is our pattern. Okay? If n is the number of number of terms that we have, so out here, I don't know, next one would be 6 and then ... I don't know, the nth term, maybe it's the 100th term. So what would the 100th term be then? We'd say 3 times 100 minus 2. So it'd be 298. If the nth term, if it was the 100th term, that's what it would be. So the 100th term is equal to 298. Or whatever term you'd like to find, once we know the formula. All right? So play around with that and see what you can do for 40.